Good morning, New Zealand. Welcome to Colab21. I'm really excited to be virtually with you. Wish I could be there in person. Scott wouldn't let me. For context, my name is Chris Giattina. I'm an architect. I'm a manufacturer. I'm a builder. I run a company that I founded called BLOX, and we design, manufacture, and construct complex healthcare for some of the nation's largest healthcare providers. We have a team of about 600 people, architects and engineers and logisticians and computer programmers and manufacturing experts and a host of other people that together work under one roof to create a condition where we can change an industry. Our talk today is platforms, programs, and projects, rethinking facility delivery with a product mindset. I'm going to have to explain what that means. So let's start with the current state. The current state is a project mindset. And a project mindset starts with an owner who has a need. And that need may be a building. And the building then creates a project. And the project then says we need an architect, we need an engineer, we need a contractor. If the team's really working well together, they will come up with ideas that may be ad hoc prefabrication. And they will start thinking about ways that work, which is really good. And so this is a positive way that works on a project. And if the owner has another project, they start the same process again. And there's another group of architects and engineers and contractors, and there's some more ad hoc prefabrication. And this pattern repeats itself in a project mindset each time. And what you get out of that is what I call the groundhog effect, which is there's very little transference of intellectual capital from one project to another project. So there is an unleveraged scale involved in this piece, which means that our overhead scales linearly instead of incrementally. And ultimately, there's very little speed to market in a project mindset. So the project mindset is the current state of our industry. And what we're trying to get to is to the future state, one of a product mindset. So this is an LG washing machine. It is a product. It is made in South Korea by the tens of thousands. A thimbleful of detergent and a thimbleful of water will sanitize my 3 teenage boys' clothes. It's an impressive machine. It needs 4 things to work. It needs water, it needs power, it needs a place to discharge, and it needs a space for it to fit. If it has all of those 4 things, it is an incredible tool. In the absence of any one of those 4 things, it's a worthless boat anchor. So what we learn about a product mindset is it requires an ecosystem in order to exist. That ecosystem is what makes it useful. So the architecture, engineering, and construction world has an ecosystem that is built for a project mindset. For that first slide that I showed you of Project 1, Project 2, Project 3, and Project 4. We knew that we couldn't get to a product mindset in an ecosystem that is designed for projects. So we changed it. This change was towards nouns, architecture, to verbs, to actions, design, to manufacture, to construct. These things are thought of in this ecosystem as a singularity, where design, manufacture, and construct is a single action. It is not a series of parallel siloed actions. Really, really important. So what we want in this ecosystem is to teach a legion of designers to leverage manufacturing productivity so that we can simplify construction. If we can do that, we can begin to change an industry for the better. We'll know it when it does this objective, 2 by 2 by 2, twice as good. We want demonstrative quality improvements. Everything that comes out of the shop needs to feel and touch and act twice as good as what the stick-built version of it is. The second one is it has to be delivered from an end-to-end perspective, from the beginning of design to the certificate of occupancy of the building, twice as fast, speed. And finally, it has to be delivered in such a way that it inures to value to the owner. It has to create twice the value. So this 2 by 2 by 2 is not an incremental change, it's a geometric change. It is 2 times 2 times 2, which is 8x improvement. We're not looking for an 8% improvement. We're looking for an 800% improvement. The industry focuses on a paradigm which takes an idea and moves it to a design, which moves it to a model, building information model, which then goes to construction documents, which are given to a general contractor, which are given to subcontractors in pieces, which are then required for a series of submittals, which go back to the GC, which go back to the architect, which go back to the GC. You see a pattern? Which go to the subcontractor, whether approved or rejected, which ultimately get fabricated and then installed and then punched, and then somewhere way down here, the owner gets to use this piece, right? So this is our paradigm, and almost all of the construction tech that you'll hear talking about is shortening the gaps between this. If I can reduce idea to design, if I can use technology to reduce design to module or to model, if I can increase the speed with which an RFI or an ASI can be returned, then I can begin to improve that. But it won't get me an 8x improvement, all right? So what we had to do is look for a fundamentally different way to get to 2 by 2 by 2, and it wasn't within this original path of the AEC industry. We said we'll go from a model and we'll go to fabrication. And instead of shortening the gap between these two, we'll just simply eradicate it. We'll eliminate it. Now, parenthetically, you could imagine that we probably ruffled a few feathers in that. But this is what we have to do. We have to go from model to fabrication. When we do that, we change the game. So we take that, and in order to make all of that work, it requires a platform. So if you remember, the title of the talk is Platforms, Programs, and Projects, right? So it starts with an ecosystem or a platform, and that platform takes the building information model and it coordinates raw material, which is then digitally processed, G-code, into specific parts, which is then put together by operators, not necessarily by skilled tradesmen, into sub-assemblies, which are installed by operators into two-dimensional panels, which can be aggregated into three-dimensional modules, which can be further nested into large Uber modules, which I'll explain later, which can then turn into buildings. So this is our platform. And it is the way BLOX is beginning to undertake changing an industry. So it is important to not think about this as a linear process from A to B or 1 to 7. We think about this as sometimes the situation, the exigencies on the site mean that raw material need to go straight to sub-assemblies because we have a really brilliant supplier. Or maybe we have a part that can go straight to the job site. And maybe there are hundreds of other exigencies that will require different neural pathways to find an optimal path from a raw material being converted to a building at the end. That's our objective. So underneath that portion of the platform is technology. That technology we have is called Weaver, and it's simply about tying disparate things into a whole. Weaver is raw materials organized digitally with a series of constraints, size, shape, location, capacity, skills, etc., organized in such a way that they reside on the cloud and that they can be produced into a digital catalog, which an owner or user can pluck out of it. At the same time, there's another half of this, which is there are manufacturers, actual physical, real-world manufacturers that can use this data to make parts. These parts then ultimately are delivered not just as a digital format, but as a physical artifact, right? So this is an important component of what it takes to change a platform. If you peel back and look at what that platform is underneath it, it looks like a series of routes, and it starts with raw material, standard parts, and non-standard sub-assemblies that can be aggregated to groups. All of these are components that work as part of the platform to produce bespoke or relatively bespoke derivative products that come out of that platform. Specifically, that platform is is a container which holds the design, manufacture, construct DMC operating system. That operating system has analog components and digital components, rules essentially. These things are constantly being developed, but they have a concreteness right now. The second one is it organizes the components. It organizes the applications. So if we were to use the analogy of the Apple phone is a platform, then the Waze app is an application. And then ultimately there are services, things that take the platform and extend it beyond just the design, manufacture, and construction, but the service life of the building. So these pieces go together and they organize external events like the supply chain. They create kits of parts which may be made by BLOX, but they may also be made by other manufacturers. They create standard modules and all of the DNA that's associated with that. They create the configuration tools that make new modules. And they create building program pieces. So all of this platform exists a priori before a project starts. Once a project starts, it pulls out of this. So step one is there's a project one. And then step two, there's multiple projects that come out of that. These projects are really products, which then allow us to scale this thing incrementally and then geometrically, right? And so this is the way the DMC platform works. It creates a condition where our gains accumulate. Our products are pulled out of the platform where we leverage scale, which allows us to aggregate demand, which allows us to create a supply chain that's responsive to this. It allows us to scale our overhead incrementally instead of linearly. It allows us to develop robust standards, digital and analog, that allows us to expand this across a wide group of people. And it inures to speed, which in many cases, provided that the quality is there, adds value to the owner, which is more than the sum of the parts. So the path to 20 clinics in 12 months is the way we're going to talk about this journey that we've been through. I think it's worth noting that it was during a pandemic, but who cares? So we start with this notion of complexity and utility, where complexity is measured on the vertical axis and utility is measured on the horizontal axis. And what we're looking for is ideally low complexity, simplicity, and high utility. And so there's a curve that says that if you started at 0, 0 and moved up, to get more utility, you add complexity, all right? And so every year, the AEC industry, our brothers, start right down here at 0, 0, and one of those brave souls gets a twitch, and they say, let's move from this place that we've been at for a couple of thousand years and try and move up the complexity curve and add some more utility. And they move up, and they get scared, and then they haul ass back down to that safe spot of low utility and low complexity. We've taken a different approach. We said that what if the curve didn't go exponentially up, but what if it looked like this? What if it was a sine curve that had a hump? This hump is where all the dead bodies hang out, okay? And what if we could take a path that would go our version 1, something simple, but that would give undeniable utility, and then move to a place that was terrible, where we had a lot of utility, but a bunch of complexity associated with it. We'll show you that path. And then have a cathartic moment, an epiphany, and realize that you could get to this far side of complexity down here, right? And then the future is V4, which just keeps going. So version 1 was several years of work. Version 2 was several more years of work. Version 3 was what you saw over the last 14 months. And version 4 is just a little hint about where we're going. So let's start with standard modules 1.0. We have some really great institutional clients, some of the largest healthcare companies in the world. They came to us with a stack of drawings, threw them on the table and said, tell me how you're going to standardize this, because they had a whole array of building types. New hospitals, old hospitals, vertical expansions, horizontal expansions, new clinics, old clinics. And they said we have robust design standards that come at a department period, but we have this amount of variation that is inescapable. And so we looked at all of this and said, wow, let's study this intently. And we said, despite your design standards, you didn't have intelligence standards. They couldn't be converted into action. The action made them become an array of variations. These are, pretend this is emergency department and these are exam rooms, and there were hundreds of exam room types, or a patient room and there were hundreds of patient room types, even though their standard only allowed for 4 or 5. We found a way to compress those pieces to a series of standard modules, known intelligence standards that could be produced in such a way that you could deliver them to the same department standards, and they could populate this array of pieces. It was a pretty major step in our timeline where this amount of variation got reduced to this amount and could still achieve the end game. So the first step was to eliminate unnecessary variation. Once the unnecessary variation was eliminated, we were able to standardize. And what I mean by standardize, we could really create robust, intelligent parts out of these pieces, much the way the automotive industry works. Once we could create standard parts, we could begin to create interchangeable parts. We could create a series of parts that would work for a client that could be used from Miami to Maine, from Georgia to California, which was really exciting. So we did these 3 things. We looked and understood intelligently how to remove unnecessary variation, keeping the necessary. The necessary variation was then standardized. The standardization then was turned into common denominator parts that would work around many regulatory zones that would allow it to be used so that we could order in bulk purchases things that we didn't know where they were going to go yet, right? Which allowed us to level load our lines, which allowed us to level load our supply chain, and it began to really change the way we thought about this. The cool thing was, if we look at a graph of a cost of stick built was the baseline, and in the beginning at low volume, stick built was the same as it was at high volume. Unfortunately, we were more expensive at low volume, but as we added volume, we dropped our cost significantly, and our prices were able to be reduced as well. So this area right here was reduced in a matter of 24 months by almost 30%. Pretty big moves. That takes us to the freestanding emergency department, which was the second step on this complexity curve. This one causes me, we're still making this one, and it's still, every time I look at it, my spine tightens and I get chill bumps because we have so much complexity in this that it hurts. We started, though, with knowing that if we were going to get to the next level, we had to develop substantially larger parts, and more of the building had to be modularized. We used the Boeing chunking approach. Chunking is a great idea. It just says we'll build this Dreamliner, the most advanced airplane ever, in a way that we'll use 22 big chunks, 10 or 12 countries. We'll ship all of these things together and put them together in one place. So this is a chunk, huge chunk. It has all of the pieces down to the paint job that's associated with it, which connects to the other chunks. This is the assembly plant in Charleston, South Carolina, where all of these parts go together. This is what we want the construction site of the future to look like. This is what we modeled this approach on. Our chunk, our module, is called an Uber module, not because we like ride sharing, but because it's the largest thing that can move on a Department of Transportation right of way in the North American road systems. So it is translated 4 meters wide, 4 meters tall, and up to 20 meters long, jam-packed with complexity. That Uber frame, though it can vary in size, all of the connections are standardized. We have digital fabrication that allows us to make that in basically any shape, so that we can create a central plant, a CT module, X-ray lab, and the list goes on, and it adds over time. This goes back to that digital catalog. All of these things reside a priori before a project starts as well-defined components. This is a building information model of that freestanding emergency department. Remember, this is an acute care hospital. This is a complex life, critical life building. You can look at all of the pieces in it. It's pretty heavily modeled. If y'all are thinking building information model of 300 or 400, think 5 or 6 or 7 in this. This is one of the components that's broken out. It is defined by the Uber module. It has an enormous amount of complexity in it. That complexity is broken down into parts. This happens to be an MEP, multi-trade racks, which breaks down into sub-parts, which breaks down into a bill of materials, which breaks down into a specific elbow, which then works with our in-house software that allows us to develop pretty rapid bills of material for those parts. It allows us to coordinate and basically distribute those pieces, turning it into a G code, which makes bespoke parts out of standard parts in such a way that we begin to really change the supply chain. This is what it looks like as one of our first iterations of our Uber module line. It's here from 1, it actually goes to 20. You can see it's a raw frame and it has systematically adding pieces. Sub-assemblies are being fed from the side. This is that same piece being installed at a job site. This is one that's being flown in to connect a large span space. So this is a 60-foot span. This gives you, if you just pause a second and look at this, this gives you an idea of the level of complexity. There's a lot of stuff that's happened today in this building. This was a slab and a knee wall at breakfast time, and by lunch, you're looking at a piece of building that has an enormous amount of geospatial complexity of building systems, mechanical, electrical, med gases, life safety. So this is all coming in one day. So what you're talking about is a lot of complexity, but a lot of utility. This is what it looks like when it's finished. A nice little building. The next step in the journey was our clinic program. And this is where we had a large international client that wanted to build 500 clinics in 5 years, starting during the pandemic. Challenging piece. We were motivated, moved to do this because what their objective is to create accessible and affordable health care for Americans, which is something that was near and dear to our whole team's mindset. So we embraced this challenge and then developed a system that could begin to think about how you could get to 500 in 5 years, 100 per year, which would translate all the way down to opening 2 a week, right? Which is a crazy pace. We're not there, but we're on a path to get there. And this is how we got there. So we're sitting up here at V2 and so there's no way we could take that level of complexity and get it into these clinics. We had to think of a way to remove complexity and increase utility, which is trying to move down here. We were at a job site. We had a problem at one of these pieces, and I'm sitting there working on this new program while working on the old one, and it occurs to me that we have taken the traditional centralized delivery of systems approach and translated it literally into a modular DMC approach. The problem with that was every connection that you saw in that picture was magnified by 100 times because there were 20 modules and each one of those had to have 100 connections in it. By the time we finished, there were thousands of connections that had to be made in the field. And we said, what if we reverse this thinking of having a centralized notion of delivery of systems, building systems, and take a decentralized approach. And that's really what led us to get to this spot where we could fix things. This is the basic clinic, and it's broken up into these modules. These modules are interesting that instead of pulling from a central plant and bringing wires and med gases to each one of those pieces, we treated each one as a wholly separate piece that was connected with one port on the outside of each one. This seems pretty obvious to you guys in New Zealand, but in Alabama, which is where I'm from, we're slow and it's the South. So it took us millions of dollars to figure out that, which I just told you for nothing. And what it allowed us to do was to radically simplify. It increased the complexity of manufacturing, but it decreased it in the field, which is where our biggest constraint was. So this is what it looks like doing the whole piece. So let's look at the metrics of how this thing ends up. We're going to look at the baseline, which is a stick-built duration. We built a few by stick in the beginning as we were tooling the plant. And it's roughly 180 days to get one from design into the owner's hands so that they can use it. We did our 20 projects and we started a little bit faster, but rapidly improved. Here you see an increase again. This is where we changed states, which meant we had to kind of go through a regulatory adjustment. But at the end, we're hitting 66% improvement from a baseline. So not quite 2x faster, but approaching that. We're trying to get this to 45 days. The second one is we can look at cost, and the baseline cost was the gray line here, which is a stick-built piece. And where we are was we started more expensively and rapidly by project 5 or 4. We were already below it, and then we kept moving down. You can see this kind of corresponds with that bump in the speed, which is when we move from a state to another state and have to go through some regulatory hurdles, and then it moves back down. So this 33% is pretty exciting. So we're starting to see value. We're starting to see speed. You saw the video. You can get an idea of the quality. So all of this is starting to happen this year, where we're producing one clinic every 2.5 weeks and delivering that to the owner at every 2.5 weeks. So pretty overall amazing for us. We're happy to have been part of that, or to be part of that. This is kind of an idea of how you can see how 20 clinics were produced in 3 states in 12 months. So we'll get to the last step now along that complexity curve. It's where we're headed today. This is just a teaser. We've got stuff that I was just at a job site in Katy, Texas yesterday, where we're putting this first piece in. It's pretty exciting. It's patient beds, so we're talking about acute care facilities, overnight stays for a rehab hospital. It starts with this idea that we've been working on for several years, which is a universal patient room, a place that is able to handle an ADA patient, a med-surg patient, a rehab patient, etc., in such a way that it can be a standard that's used and deployed in a best-in-class way in many different departments. This is what it looks like. So it's a handsome room. It's organized in an Uber module. So this is one half is a patient room. This is the other half. The corridor moves through the middle of it. You'll see there's a column here in the middle of the 8-foot corridor, and that is a temporary one that goes away. We'll talk about how this is one module that can be used both for the left hand and the right hand. So that allows it to be bilaterally symmetrical around its central axis. So this is what it looks like broken down. This is the above ceiling. We'll take a picture, we'll take a mental note of that, and we'll see how the patient room Uber works with the structure. So the structure members are here. There's a temporary member here in the middle, which is allowing us to ship these 20-meter long units. And then you'll see the MEP connections, which work with the other sides of it so that you can create connections that are very easy to stitch together. This is them on the line right now. So if you go out behind this wall right at this moment, you'll see a line filled with patient rooms. These patient rooms are being deployed in 4 states right now, and all of those are working with the standard patient room module. This is it. This has not been edited. This is off of the construction cam from yesterday or from last week. So we set these on Wednesday of last week, and today I'll show you. I was at the site yesterday. I'll show you what that looks like. So a week ago, you were in a spot where you had a couple of these ends that were being added to it, and there was a knee wall to receive the other units. And so Wednesday of last week, it is here. And then today, you're looking at a picture that has RTUs on it that's energized, and the inside's being connected. So the day we installed it a week ago, it looked like this. That's that interior column looking down a patient corridor. This is it. I took this picture yesterday. The column's removed and the MEP's stitched, right? So imagine that we went from a slab on grade to this level of completion. You could see painted walls in a really, really short period. In order to do all of this, there are a series of conditions that you need to think about, or that I would encourage you to think about, or that we have thought about. The first one is a product mindset. It's what we talked about. Divorce the notions of project by project. You won't get the leverage that you need. Think about the ecosystem, how that connects to a platform. It can be yours, it can be someone else's. We offer ours if you're interested in it. To ultimately move a project that's extracted from an ecosystem which is designed to do so. The second part is we normalize the deal flow. Okay? So what we want to do is create a continuous deal flow that allows the supply chain to normalize. So you have to think about the entitlement process, the development process, the occupancy, filling up with the docks and the other pieces. All of these things have to work as part of the overall system. You can't think about your silo any further. It has to be driven from the top. So if you have a client that's not interested in driving this, then they're not ready for it. Go conventional. When you have the few clients that begin to embrace this in New Zealand, they will start to see the power of the method, and they will drive it from the top, and it will make your life easier. So look for ways to make that happen. The fourth one is you have to normalize your supply chain. The supply chain is built on a 12 or 14 or 16 month cycle. That doesn't work when you're producing a building every few weeks. You have to begin to develop strategic relationships and work diligently to take your aggregated demand and transfer that into a currency that allows them to want to work with you. And then ultimately, we are going to aggregate demand using a platform across clients and across programs, right? So this is real leverage, which is when we use a platform mindset that allows us to do a hospital, a clinic, a freestanding emergency department, maybe a house, maybe something else that's still using all of these same components that happen off of a platform. So I'll leave you with that, New Zealand. Thank you for your time. I'm available for questions.